This big lab goes over many subnetting processes, so I'll walk you through those, show you the answers to each of those steps, and then cap it off with that configuration that makes it all work. So this content happens to match the official Cert Guides Volume 1 and Part 4. You'd want to get through the end of that part, and it really covers everything in the part, or most everything. So in that part, in both the course and the book, there's a chapter that's kind of an overview of everything with subnetting, but just to give you the context, and then 4 chapters that drill down on specific tasks. You want all of that coming into this exercise. So what did I ask you to do in the intro video that spells out the tasks? I want you to find the lowest and highest subnet IDs of 3 different networks, and then plan which of those subnets to use in the locations needed in this network topology. Then for each of those individual subnets, you needed to calculate what are the ranges of usable addresses in those subnets and pick specific addresses for the LANs and then for the WANs in step 4. Then at the end, I said, let's create the configurations that match that, and you could even go deploy that in a Cisco Packet Tracer file. So that was the lab exercise in short. In this video, I'm going to review all that. So task 1, 2, 3, and 4, that's all the subnetting math. I'm going to take those one at a time and walk through that. And then at the end, I'm going to show you the configuration, which honestly, it's not a lot of configuration by volume, but it just matches up and shows you those same IP addresses and masks and default gateways that you would have planned as a result of all your subnetting math. All right, let's get into it. Let me start by showing you the answers because you may not care to look at how I got the answers if you know you got it right. So in the Class C network 192.168.90 with this mask, here are the numeric first 3 and last 3 subnet IDs. Then same thing, Class A network 10 with this mask 255.255.240.0, numerically first 3, numerically last 3. And then finally one more. That Class B network 172.20 with the mask with the 254 in the 3rd octet, first 3 and last 3. But if you didn't get those answers and you want to see how to figure out those, next few minutes I'm going to describe how. So I just wanted you to find the first 3 and the last 3 subnet IDs of those 3 networks, and there they are with different masks. And I'm going to go through in detail this Class C example, a little bit of detail on the Class A example, and then just a few words on the Class B example. I've got several videos on this topic and a practice exercise on it, so I'm just going to give you a little bit of shorthand on this. So that Class C network 192.168.90 with this mask of 3 255.252. What are the subnet IDs? Well, our magic number in the 4th octet is going to be 256 minus 252, or 4. So we're counting by 4s in the last octet, ending with the one that has a .252, because if we added 4 more, you'd have a 256. All right. So that's a shorthand version of how I might be thinking once I'm good at the process. But just taking you through the long version on this one. You start with a classful analysis. We're subnetting a Class C network. That tells us we have 24 network bits, meaning all of the first 3 octets are network bits. Those are network octets for our process. Then more analysis shows us 6 subnet bits and 2 host bits. So we treat this 4th octet as a subnet octet for our process. That's where we're going to increment to find successive subnet IDs. So we set up our workspace with 3 wide for our network octets and 1 wide for our subnet octet. The first subnet ID is always equal to the network ID. We call that the 0 subnet. And we can copy down the octets that are network octets over here, and then we're going to add something to make the rest of the subnet ID add something in the subnet octet. The something is the magic number or increment. How do we calculate it? 256 minus the mask's value in that octet, or 4. So we keep adding 4, add 4, add 4, add 4, add 4. We get to 252 and stop there. We know to stop there because if you added 4 more, you'd be at 256, and these numbers can only be between 0 and 255. All right, so that's out of range. It's an illegal value. The one before it is the broadcast subnet. All right, so that gets us through the example for how to find the first 3 and last 3 numerically of that particular Class C network with that mask. Then you'd have to do the same for network 10 for this exercise with the mask that I asked you to use of 255.225.240.0, and this one is trickier. The reason it's trickier is once you do the classful analysis, you'll see there's two subnet octets, but there's the answer. Here are the first three and the numerically highest numbers, the last three, and notice these have a 255 in that second octet. That's probably the most likely place where you might have gotten a different answer. So let me focus on that part of the answer. When you start your process, you did your classful analysis, and what you would have found is that all of the second octet and some of the third octet had subnet bits. So it turns out that's one of those cases where I gave you a special case video to explain what do you do when there are more than 8 subnet bits. And when there are, you have to expand your process, where you create a block of subnet IDs, where you add the magic number in the rightmost of the subnet octets, with a 0 in the leftmost of the subnet octets. And then you create another block with this same pattern on the right, with 1s on the left. Another block, same pattern on the right, 2s. Same pattern, 3s, same pattern 4s, all the way up through the same pattern with 255s, and then you're finally at the end of the list. All right, so these were the last 3 that I had in my answers list over there just a few moments ago. So that's the last block. So that's the tricky part of finding those last several subnet IDs. Then for the last network in our list of 3, 172.20.0.0, with this mask, it was the most straightforward option probably. Here are the first 3 numerically and the last 3. And the mask to get there, you write down the network number as the 0 subnet. The magic number is 256 minus the mask value in that third octet, or 254, giving us 2, so our increment is 2. Add 2, add 2, add 2, add 2. You stop at 254 because if we add 2 more, you get to 256. That's your pattern, counting by 2s in the third octet, and those are your subnet IDs. Once you had calculated all the subnet IDs, task 2 was straightforward other than sifting through all my instructions, all right? So that might have been the struggle in task 2. So in the instructions, I had this table that said subnets 11 and 12 needed to use subnets of network 10, but specifically subnet 11 uses the lowest subnet ID and subnet 12 is the second lowest. Also, subnets 21, 22, 23, subnets of Class C network 192.168.9, but they respectively use the highest, second highest, and third highest subnet IDs, and similar rules here for network 172.20. So following those rules, if we look at that map, here were the generic references to the subnet IDs, and then for network 10, those were the subnets on the left, subnet 11 and 12. We said, hey, we want subnet 11 to use the first one and subnet 12 to use the second one. Those were the subnet IDs down here in this table, so just copying them up there to our drawing. There's subnet ID 10, which is also the 0 subnet, and subnet ID 10.0.16.0 with that same /20 mask there on the left. So it might be a nice reference to have on your scratch piece of paper to say, all right, well, what are the subnet IDs? Just put them into your network diagram. Following that same logic, we had subnets 21, 22, and 23, and the rules were that we wanted to give subnet 21 the numerically highest, 22 the second highest, and 23 the third highest numbers. All right. So going back to our notes of our calculations, here was the third from the end of the list, ends in .244, second ends in .248, and the last one ended in .252. So the numerically highest one is at the end of our reference table there. Our instructions said give that to subnet 21, the one that ends in 248 to subnet 22, and the ones that ends in 244 as the location for subnet 23. Again, I'm just matching up to what the instructions said in the exercise. And then finally, here are the numerically lowest 3 subnet IDs of network 172.20, and the instructions said to assign those respectively to subnet 31, 32, and 33 in the diagram. So we get that subnet ID for the top, the one with the 2 in the third octet for the second one, and the one with the 4 in the third octet for the third one. So to plan which IP addresses to use, you have to calculate what are the IP addresses in those subnets that you've chosen in those different locations. So you've already figured out the subnet ID, and then you can calculate the subnet broadcast address. From there, you can figure out the first or lowest IP address by adding 1 in the 4th octet to the subnet ID, and to find the last usable address or the numerically highest usable address, you subtract 1 from the 4th octet of the subnet broadcast address. Now, if you're using the same 8 subnets that I directed you to, or the ones that I think the directions directed you to, here they are. Those are the subnet IDs. And if you add 1 in the 4th octet, you get these values in the next column as you see here. And by the way, as a reminder, the instructions said use the lowest address in each subnet for the PCs, so there's a reminder. Additionally, here are the subnet broadcast addresses in each case. So you can review those, and here are the highest usable addresses that the directions say use for the router interface addresses. So this one ends in .255, the router would be .254. Notice that some of the broadcast addresses don't end in 255, like this one ends in 251. The last usable address is 250. So you can hit pause now and check your math to make sure you got everything right. Then once you know things are right, you can look around in your LANs and say, well, which devices need to use which addresses? As a reminder, the general instructions were PCs use the lowest address, routers use the highest address, and the switches use the second highest address. And the PCs and switches need to refer to the router IP address as their default gateway. So walking through the specifics then, on the left-hand router, R10, and its attached devices, PC 11, lowest IP address in subnet 11, switch 11, second highest IP address ends in .253, has a 15 in the 3rd octet, and the router address ends in 15.254. That was that highest IP address in that big table that we just looked at. Then on the PC 12 and switch 12 has the second highest address, ends in .253. The router has the highest IP address, ends in .254. PC 12, lowest IP address, 10.0.16.1, as you see there. Moving our attention over to the far right to those 3 LANs. Those were the ones that had subnets of network 172.20. PC 1, lowest IP address. Switch 1, second highest IP address. Router R1, highest IP address. You can refer back to that table. And then likewise, similar approach then for the 2nd and 3rd subnets. For the WAN IP addresses, look toward the center of the table to subnets 21, 22, and 23. Now note that the masks are /30. That means you'll have a subnet ID and subnet broadcast address, but only 2 usable addresses. Notice .253 and .254 are the edges of the range, .249 and 250. In fact, only 2 usable addresses per subnet. Each of those WAN links only need 2 usable addresses. So if we look at, for instance, R10 to R1, we just need an IP address on the opposite ends, so only 2 addresses. Our rules for this exercise were to give R10 the higher address in the subnet and the other router the lower IP address in the subnet. So knowing all that, it should be straightforward to pick the addresses. For instance, on the R10 to R1 link, R10 gets the higher address that ends in 254, R1 gets the lower that ends in 253. Likewise, on the R10 to R2 link, R10 gets the .250 address, R10 gets 250, R2 gets 249, and similarly, R10 gets 246, and R3 gets the .245 address. Next, I'm going to look at the config with you, but I'm going to break it down based on the areas of the topology. So we'll first focus on LANs on the left side of the diagram. That is the ones near router R10, with R10 connecting to switches 11 and 12 to create those subnets. All right, so focusing on R10 first, it's got those 2 interfaces. The upper interface was gig 01, the lower one gig 02. And on the upper interface, it has an IP address from the numerically lowest subnet, but it's the highest address in the subnet. And from that table, you might recall it's 10.0.15.254. with the .255 number being the subnet broadcast address in that case. So there's the command to configure it, IP address, followed by the address, and then the mask in dotted decimal format. Similarly, on the lower interface, gig02 IP address, but then the numerically highest address in that second subnet ends in .254, so 31.254 here. That's the config on router R10 on the LAN interfaces at least. Then on the switches, they both need to point to a default gateway that is that router's address. So as you notice here on switch 11, IP default gateway as a global command that refers to the router IP address. So I'm just using the arrow line to emphasize that's the address it's referring to. And likewise, the default gateway pointing to R10's gig02 interface address, 10.0.31.254. Then for the IP address on the switches themselves, I told you, hey, the management VLAN is VLAN 1. It's the only VLAN. We want to configure the IP address under interface VLAN 1. So there's the interface VLAN 1 command, followed by the IP address command with the switch's IP address ending in 253, 10.0.15.253. That's the second highest address. And then similarly, 10.0.31.253, one address lower than the router's address. All right, now moving over to the LAN on the right, or the LANs on the right, we've got branch office router R1, R2, and R3, and they're connected switches 1, 2, and 3. Focusing on the routers with their LAN interface only. The LAN interfaces were all gig00, by the way. They've each got an IP address command. Here's that numerically highest IP address in the first subnet in 172.20, numerically highest address in the second subnet of 172.20, numerically highest address in the third subnet of 172.20. Then those three switches, respectively, need to refer to that router's IP address as their default gateways. You see that configured in the global commands there that have the arrow line pointing over. And then the address of the switches, again being configured on the VLAN interfaces, 172.21.253, one less than the router's address, just because of the rules of this exercise, not for any other rule, saying, hey, use the second highest address for the switches, second highest address in the second VLAN, second highest address in the third VLAN. Now, how about those WAN links? Well, we've got 3 WAN links, R10 to R1 on that WAN link. We've got the 192.168.9.254 address with the lower .253 address over on the right on R1. The center WAN link ends in .250 with the one lower address .249 on R2 on the right, and then same pattern per the exercise instructions at least. .246 on the left on R10 with .245 on the right on R3. So let me walk you through a demo real quick. You can use your file so you can compare what you see in this video to what's working in your file. However, if you struggled with getting things working in Packet Tracer, I've got an answer file in the description as well. You can download that and open it, and it's configured just like I used here. In fact, I did the demo from the answer file that I posted. So in the demo, I'm just going to look at the router addresses. I'm going to look at some IP routes in the routers. Then on the PCs, I'll do a TraceRoute command to trace the routes through the network and prove that the PCs can send and receive packets from each other. So here's our network topology in Packet Tracer, and I've already opened up router R10, and I've gotten into enable mode already. So a couple of commands to try: show IP interfaces brief, or interface brief. And we see this list of interfaces, and we see IP addresses, but no masks with this command. But if you look around, we'll see the 2 LAN interfaces with their network 10 IP addresses, and we see the 3 WAN interfaces with their 3-digit interface numbers, and we see the 192.168.9 addresses in those, and top to bottom ending in 254, 250, 246 for decreasing subnet IDs related to those addresses. Now, if you did care to see the masks, you could do show protocols, and you'll get a couple of messages per interface, and you see the mask of /20 on those 2 LAN interfaces, and you see the mask of /30 on the WAN interfaces. Now, I told you that OSPF was running, but even without OSPF running, you should see connected routes for all the interfaces that are in an up state for which you've configured an IP address. So a show IP route connected will show you 5 connected routes related to the IP addresses we've configured. And this one's interesting in that it will show us the subnet IDs we calculated earlier. So here's subnet ID 10000, that is the 0 subnet, same number as the network ID, and subnet 10160, that's the second lowest subnet numerically. And then we see those 3 numerically highest subnets of 192.168.9, the subnet IDs ending in 252 and 248 and 244 with that /30 mask. Now the other routes are learned by OSPF, and so you can do a show IP route OSPF command as it turns out. And by the way, these are things that are covered in the upcoming chapters of the course, which is one of the reasons I hesitated even to make the exercise, but I figured, hey, I can at least explain some of this to you and you'll be a leg up on the coming material. But this command, show IP route OSPF, shows us all OSPF learned routes. And here are those 3 subnets of network 172.20, the 3 numerically lowest. And if you were to look further into these, you would see that this numerically lowest number is reachable via the address that's configured over on router R1. And this middle one is reachable through the address that's configured on router R2. And this last one is reachable through the IP address that's configured over on router R3. Next, let's look at those same kind of things over on router R1, one of the branch office routers. So a show IP interface brief command will show us those 1 line per interface, and those branch office routers have only 2 working interfaces per this design. We've got the LAN interface with its 172.20 address and the WAN interface with the 192.168.9 interface. This command doesn't list any masks, but show protocols does. Just have to hit the space bar a few times. And here we see the /23 mask in use with the 170.20 IP address we configured and the /30 mask over there on the WAN interface. The routes are where it's at. So if we do a show IP route connected with 2 working interfaces configured with IP addresses, we should see 2 connected routes. Now, the routes show subnets. So here's the first subnet. It's the numerically lowest of the 172.20 subnet IDs. And here we've got the numerically highest of the 192.168.9 subnets listed there as it turns out. The rest of the routes are learned with OSPF. So show IP route OSPF. And then we see several. We see 2, the 2 in network 10, the ones that are on the far left of the diagram. Here they are. We've got 2 other subnets in 172.20. Those are the ones off of router R2 and R3, the LAN subnets. And then 2 more. These are the WAN subnets that are connected over to router R2 and R3. They're remote from R1's perspective, so we've got those there. To finish the demo, let's look at one of the PCs. To configure those, you could go through the Config tab once you click on the icon of the PC. So you go up to Settings and you can set the default gateway. In this case, we want to point to router R1's upper interface IP address, the one that's in the same subnet, which is 10.0.15.254. And then you click on the interface, in this case Fast Ethernet 0, where you can configure this device, this PC's IP address. It's the numerically lowest address in this subnet, or 10.0.0.1, and you configure the subnet mask there as well. For testing, you can go over to Desktop and Command Prompt, and you've got a command prompt like this one. You may have seen some other commands I had tried earlier, so I can up arrow and just retrieve some of the commands I tried. So this is a TraceRoute down to PC 12 from PC 1. It completed. That shows me that, hey, there's connectivity down to PC 12, and just to show the rest of them working, that's the IP address in the TraceRoute command over of PC 1 off of router R1. So we can do that. That TraceRoute completes and it shows the routers in the path to reach that destination. Go back and ping PC2. We're confirming connectivity over there. And finally, I'll do the same with PC3, confirming connectivity out there to PC3 as well. Well, that's truly everything related to addressing and subnetting here in part 4 of volume 1 of the book and course. So if you're ready for the next content, click on the video on the left for the first one in part 5. However, if you don't have your plan down for how you're going to keep practicing subnetting until you really internalize it, click on the right for the part 4 part review video, which is mainly about how to go about mastering subnetting. Hope you're enjoying your time here. I'll talk to you soon.